All right, so we're just leaving off with determining measurement. And what we talked about last time, among other things, was that there could be an element that involves having to convert the units. This stray line is just going to be a reality for us for the time being. So we just got to kind of have to deal with it. I do have to reference my tablet every once and again to see what problems we need to do and which ones we don't. So on the next page, we have the bottom problem. Yeah. So I'm going to get out my ruler and use that wherever it is hiding. There you are. To determine the measure in inches. All right, so hopefully it works the same way here as it does on the thing, on the desktop. Where is the circle? It's going to turn into a circle somewhere. No, that's just for moving it. Okay, there it is. Yeah, I got to use the mouse. Not completely mouseless yet. Although one of my students at the high school just got a device. It's basically, honestly, I didn't have the heart to tell him, but it looked like a set of brass knuckles. But it's completely digital, and it's so that you could type with one hand, but also it functions like a mouse. So I thought that was pretty cool. So your gestures, if you think like Tony Stark, you know, like when he would throw stuff up in the air and swipe over, like it's pretty much that. It was honestly one of the cooler things I've seen. Just because, you know, like we got to get there eventually, right? We got to get to Back to the Future technology at some point. Right? So the ruler is telling me that we're looking at, if I'm counting in terms of inches, that we're looking at, it looks like 2 3/4 inches. Now, that's operating under the assumption that this is scaled properly. So we're just going to kind of go with it. But I mean, we have a ruler telling us that it's 2 3/4. If you got something different, that's fine. But 2, you can write, and 3/4 inches. All right. Key ingredient here, and when we do take a test on this, you gotta follow the instructions. It says indicate the level of precision. All right. The level of precision is basically saying what are we rounding this to? So I just make a note at the bottom. The precision would be, well, I rounded it to the nearest 1/4 inch, so it would be 1/4 units, 1/4 inches. All right, you look for the singular of that measure. All right. So if I rounded it to the nearest 1/16th, my precision would be a 1/16th of an inch. All right, so that part is pretty straightforward. Now let me see if I can navigate this. Oh, I did not know that that was a thing. And this is actually pretty archaic technology. It's from the 17th century, actually. No, it's from the early 2000s, the early aughts, as they say, wherever they are. So here I just got to work my way around. And, you know, you could kind of take liberties with it. If it doesn't match up with a particular tick mark, you can kind of sort of pretend that it does. Because, you know, like for these assignments, because on a test, I would make it so that they're, I'm not going to say perfectly crystal clear and clean, but they're reasonably clean. Right? So this one looks like we got one, this would be the half, oh, well, you don't know what I'm gesturing at. This would be the half mark. And so this looks like also 3/4. All right, but since I need the length of this figure, it's really implying that I'm going for perimeter. So I got to get all 3 sides. So far I got 1 3/4. And this is why I have my calculator out, because I'm going to have to add these up, and I might have some funky fractions involved. I might as well just pivot down here because I already have this one part already pinned down at a vertex. So it looks like this one is just shy of 2. So this is measured in 1/16ths. So well, there would be 16 of those 1/16ths in 1 inch, right? I'm falling just one short. So this would be 1 15/16. All right, now these are all inches. That's something to keep in mind, because the question's asking for feet. So we're going to have to do that conversion at some point. All right, so I need my missing side. And we might be able to draw a conclusion about the nature of this figure also. Although the question didn't really ask us to do that, while we're here we might as well. If I use my same kind of blur the vision approach of like, well, it's kind of sort of pretty much this, because that was what the intent was anyway. We're looking at another 1 3/4. All right, so this pen sucks. I can't use it. I got to write with my finger this whole class. It's going to suck. All right, so 1 3/4 inch, 1 3/4 inch, 1 15/16 inch. All right, that's all well and good. I still need it in feet. So then the question becomes, do I want to convert them all first, then add them, or do I want to add them and convert them after the fact? Well, it's one conversion if you add them first. So that's my recommendation. Right? Whether you have a fancy calculator or a simple one, it's really just a matter of adding each individual piece. All right, so just a reminder from last week, when I'm adding these three values, it's really, I gotta find a way to write with this. This sucks. This is gonna be 1 plus 3/4 plus another 1 plus 3/4 So my recommendation was to get a calculator that can handle fractions. And not because of the 3/4, because 3/4 is 0.75, that's fine. It's the 15/16. All right, so if you have one of these graphing calculators, the newer ones, you have a little bit of an advantage because there's a fraction function that's built in. So if you had alpha y equals on these calculators, it's great. You know, you could select option 2, and it allows you to just type in a mixed number. So I don't even have to break it up like I just did where I wrote it in black. I just write 1 3/4 plus alpha y equals 1 3/4 plus another alpha y equals 1 5/16. But like I said, I mean, this is not a requirement for the course. So you look at this and say, okay, cool, nice job, show off. We don't all have this calculator. Some of you, I can see, have calculators that are kind of along the same lines, similar but not quite the same. There's nothing wrong with that. It's just you got to do it a little bit differently, right? So this is going to be 87/16, and that's a nice enough number. But the reason why I wrote it out this way is so that you could just say 1 plus 3/4 plus 1 plus 3/4 plus 1 plus 15/16. Order of operations is going to take care of business for you, right? So you don't have to worry about, bothering too much with all that, fancy stuff related to calculators. All right, so you got this 5.4375. All right, so 5.4375. Now, again, it's got to go to feet. So this is going to be, and I'll just make a note, 5.4375 inches. 75. All right, so I have to convert it over to feet. All right, so that's what we're going to do. When you want to convert to feet, what we're going to do is we're going to multiply by a fraction. We talked about this last time. Multiply by a fraction that we know is equivalent, right? We know is equivalent to 1, but allows us to eliminate the inches and introduce feet. So all we have to do is, all we have to really know is how many inches are in 1 foot. There are 12 inches in 1 foot. So that's where our multiplier is going to be, and I lost it. This thing sucks. So I'm going to multiply 5.4375 by the 1. All right, so I'll multiply it by 1. I'll just show it, even though you don't need to actually do it, you know. And then after that, I'll divide that result by the 12. So divide by 12. So now we're in feet. So it's just a question of conversion into a more convenient form. All right. So if you round it, you would state whatever precision you have based on the rounding. This is going to be, if I write it in this form, I mean 0.453,125. Most calculators, regardless of whether they're fancy graphing calculators or otherwise, they have some way of converting from decimals to fractions and vice versa. This one is math and math frac, you know, the arrow pointing to frac. So math frac, and it'll convert it over 29 over 64. All right, so this would be 29 over 64 feet. All right, so our precision really, I mean, if you realize that it's just taking the denominator and the units and making a fraction out of that. It's 1 over 64 feet based off of this value. If you rounded to 0.45, it all depends on how you did it. Like some people, they've looked at this problem and said, okay, I got the 0.45. I'm going to round that to the nearest tenth. I'm going to say half a foot. I mean, why split hairs? Half a foot is not an unreasonable approximation. If somebody said, how long is that triangle? What's the perimeter of a triangle? And you said half a foot. And then somebody else said, well, it's approximately 0.45 feet. You're like, shut up, dude. You know, so like, you know what I'm saying, right? So as long as you indicate what your precision is, you're telling people this is what the level of accuracy is for the number that I presented you. All right. Now I'm saying I gave it to you to the 1/64th of a foot. All right. So I'm telling you that I'm giving you a very precise measure. If you say that you're giving it to the nearest tenth of a foot, then you're saying that you're giving more of an estimate. All right. So those, fairly easy one, or actually very easy one because you just slap a ruler on it. A little bit more complicated. 15 goes back to being on the easier side. It's really just measurement. But then 16 is the creme de la creme. So I want to change this so that I'm focused on. Oh, I had it. All I had to do is hit the arrow thingy. There it is. Come on, you son of a gun. I can't quite get it to line up, but oh, I got it. Okay, forget it. So that's 3.1. You could say 3 1/10 if you want, but it's 3.1 centimeters. I'm going to measure the other horizontal one just because it's easier to slide my ruler over. Also 3.1. That's not surprising information for me, because when I created this, I copied and pasted line segments and then just just connected them. So the one that I connected them with is about 2.4 centimeters. So this one's a lot easier in terms of the computation, because it's just a matter of simple sum. So 3.1, you could even say times 2, because there's 2 of them, plus the 2.4, and we're looking at 8.1 centimeters, or 8.6, sorry. All right, that's to the 10th place. All right, so our precision, 1 decimal place is the 10th place. You don't have to write it as a fraction. You could just say 0.1 centimeters. 0.1 in fraction form would be 1/10, right? So really all I'm saying here is just take whatever your fraction is or your decimal and indicate the singular value of it. All right. So if you have 9/10, it's still a precision of 1/10. Right? It's just as simple as that. All right. So, like I said, the big beefy one is number 16, because that's the one that involves some. So this decimal place 0.6, all we're doing to indicate precision is just taking a single unit from that. Right, the last decimal place that you have, you just grab one single unit from that, and that's your level of precision. Right, so if I looked at something like this one here, when we had the 3/4, in order to indicate the precision, all I did was I took this fraction, and I only took one of those values. So if there's 3 of the fourths, I only want 1 of those fourths. So here there's 6 of those tenths, I only want 1 of those tenths to indicate the precision. There you go. So inches and feet kind of go well together because there's an understood conversion. Same idea with centimeters and kilometers. You would not want to measure in inches and then try to convert to kilometers. It's doable, but you're just making more trouble for yourself. So let's do this in centimeters. It looks like, just for the sake of having a round value, we'll call it 7.2. That thing just wants, because it wants me to draw a line. Let me just fix that. Pop it right here. All right, then below. Extended. 9 even. Catch a break every once and again. All right, these are centimeters. Solid 3.5, so 3.5. And the last one would be, there we go. Looks like it's going to be an even 3.5. Yep. Same. All right, so 3.5. All right, so we'll get the sum of all these values. All right, so we got 3.5. Got 2 of those, so times 2. Nice 7 plus the 9 plus 7.2. All right, so it's a perimeter, but you can just indicate what the actual value is. I'll write it on the inside, perimeter. So that's centimeters. So again, we have to convert it over. We have to make it into kilometers. So that's the challenge. Now, what I don't understand, if this thing reacts to touch, why isn't it reacting to my pen's touch? Is there a better pen for these? I don't know. Maybe it's me. All right, well, anyway, so that's really all that's left. We have 23.2 centimeters. We have to convert that over. So 23.2, I think I might have just found it, centimeters. This part's twofold, because if you know how many centimeters are in a kilometer off the top of your head, congratulations. I don't. I mean, I can figure it out. It takes a couple of seconds, but it's not something I want to have to figure out every single time, and it's certainly not something I want to have to memorize. I do know how many centimeters there are in a meter. So there is, in 1 meter, 100 centimeters. Now, I can go through the cancellation process right now if I want, but I don't. Because, again, it's twofold. I want to get to kilometers. I also know how many meters there are in a kilometer. The kilo part is 1,000. All right? So there are 1,000 meters in 1 kilometer, or kilometer, however you want to say it. All right? And if you have your setup the way it ought to be, all the units that you don't want to be there should cancel away. All right, so I have centimeters divided by centimeters. I have meters divided by meters, all equal 1. So then it's just a matter of taking my, just like we did before, my 23.2, multiplying it by 1, right? Don't need to show that. But then dividing it by these two numbers. All right, so I'm taking 23.2, dividing it by, you could just do it all in one shot. If you do that, parentheses are the way to go. But you could divide them separately also. So if I do it like this, I get a value. I mean, it's a lovely looking value. But I could do it separately, like I said. I get that result, and then divide that answer by 1,000. So 2.32 e negative 4, that's something where you're like, what? Why would I ever want an answer like that? It's not a matter of what you would want. It's obviously what you're asked to do. But also, sometimes, for consistency, you want to convert from something like centimeters into kilometers, even though it might not feel right, just to make that information consistent with other information. Right? So personally, like if a person's running and they tell me that they ran around the track, so that's 400 meters in, let's say, 10 minutes. All right, so 400 meters per 10 minutes. All right, so that gives me 40 meters per minute. Is that fast? Is that slow? I don't know. I can quantify in miles per hour. I'll settle for kilometers per hour. Ideally, it'd be miles per hour. Because I know like 80 miles an hour is really fast. 30 miles an hour, slow for a car, fast for a human, obviously. All right? But like these are things that I have an idea of, But 40 meters per whatever, it just doesn't feel right. I don't know. So we convert it over to something that is a little bit more meaningful. So this is 2.32. It says e negative 4, but that's not the way we want to think about it. That's the calculator just being difficult. Most calculators have some way of representing scientific notation that's not consistent with ordinary scientific notation, which is kind of annoying. But this is the same as saying times 10 to the negative 4th power. All right, so 2.32 times 10 to the negative 4th power. All right, and all that's telling us to do is move the decimal place over to the left 3 times. So this is the same as saying 0.000232. All right, and specifically we're in kilometers now because we did the conversion. All right. So what I'm getting out of this is that it is the tiniest fraction of a kilometer. All right. Now, if you wanted to convert this into fraction form, you could try. Sometimes it works, sometimes it doesn't. Generally, with these calculators, if it goes to scientific notation, it's not going to give you an answer that is fraction friendly. But I can still state the precision. I moved it 4 times, yeah. And in doing so, one of the movements gets it beyond the 2. And then 3 more movements after that. So, no, you want to move it 4 times, but it creates 3 zeros.
Right.
So 1, and then 3, 3.
Oh, sorry.
No. I solid chance I misspoke. I mean, it is a rarity that something correct comes out of my mouth and that same correct thing ends up on paper at the same time. So you never know. So we're looking at 0.000001 kilometers. All right. So what that's telling us, or the way we know that anyway, is we go right to the last digit of the decimal, zero out everything that comes before it, and replace that with a 1, because that's a singular unit, right? I mean, we could name this if we want, because, I mean, you go right back to, I don't even know, is it early middle school or late elementary school now? Well, it's common course, it's probably like pre-K, but when you talk about naming these numbers, tenths, hundredths, thousands, 10,000, 100,000, millions. So this is the millionths place. So this is correct out to 1 millionth of a kilometer. All right, so very, very precise is what we're saying. We're also saying that this is the teensy tiniest little fraction of a kilometer, which I think you would agree with, because if I were to tell you, you know, because people, you know, Americans, we can't always conceptualize kilometers, but miles we don't have a problem with. So if I were to say, how many miles long is that figure, you're going to say, are you kidding? Do I really have to do that? It's not even like a little. It's not even a little bit. Like, why would I bother doing that? Right? So to get a number that's consistent with that is reasonable, and that's what we're looking for. Right? But this number 16 is your indicator question. If you can handle something like this, you can handle anything I can throw at you. All right, so Windows Shift